Hi, my name is Ken Johnson. I'm Director of Marketing and Product Architect at Teledyne LeCroy. Today we're going to show in this video a short demonstration of our dynamic power analysis using our motor drive analyzer. We'll change the MDA time base to capture 1 second of data at 100 megasamples per second sample rate. More or less could be used. This is a 100 megapoint acquisition. We'll also set the trigger delay to 10% of the acquisition length and the trigger level to a location that corresponds to approximately 1 amp of motor current. We want to trigger at the start of a loading event, and we'll set the trigger mode to single. We can see the results of our settings here. 1 second at 100 megasamples per second for 100 megapoints of memory. We'll increase the load on the motor and release it, simulating a dynamic operation that might correspond to a tool, servo motor, or robotics operation. In doing so, we'll capture many cycles of operation of the drive system, calculate voltage, current, and power numerics, and plot selected per cycle waveforms to investigate drive behavior. Here is our populated numerics table with all the power values. Note that we've probed line to line, but we've converted that to a line to reference basis. If I touch here in the numerics table, we'll create a 3-phase power waveform versus time. If we touch here, we'll create a 3-phase power factor waveform versus time. Up to 12 of these waveforms can be created at one time. Then we can use zoom and gate to create zooms of the acquired waveforms and gate the measurements in per cycle waveforms to the zoomed area. As I scroll the waveforms through the dynamic acquisition, the numerics table data is instantaneously updated, as are the per cycle waveforms, staying perfectly time correlated to the zoomed area and zoom waveforms. Thanks for watching this video on dynamic power analysis. You can watch additional motor drive analyzer videos or access additional content at teledynelecroy.com/static-dynamic-complete.